do?
I can't figure out reflected intensity or transmitted intensity.
Look, calm down. I feel your pain, but let's get out of this rain and do our thing. All right, Britt, go ahead and read me my problem.
All right. For an incident intensity of 2 milliwatts per centimeter square
Yes, sir.
and impedances of 49 and 51 rails, what is the reflected intensity and the transmitted intensity?
All right. So here, we're solving for reflected intensity and transmitted intensity. Now, what is reflective intensity? You know, if an object is hitting something and it just so happens to come back, that's reflected intensity. But if that object just so happens to go through it, that's called transmitted. So, to solve this problem, we need a bunch of equations, and these equations get to your problem. So, intensity reflected to solve for this. So to solve for this, we're going to need a bunch of equations. So let's start off with the equations. To solve for the intensity reflected, you're going to need your intensity reflected coefficient. And that right there is the IRC. For IRC, it's IRC, your intensity reflected coefficient, equals impedance number 2, so that's Z2, and impedance number 1, so that's Z2 minus impedance number 1, over Z2 plus impedance number 1. And you square that. So what happens when you get your IRC? You're sitting there going, I got IRC, I got a coefficient, but what do I do with that?
You're not done.
You're not done. You got to go somewhere else with it. So you take it and you say, hi, nice to meet you. My name is Randall. Can I get you a pizza? But we go ahead and take it right here. You go ahead and solve for IR, your intensity reflected, and you take IRC times your initial intensity. I tend to put initial intensity times IRC, but it doesn't matter. It'll get you the same place. And now here, after these steps, we would have solved for intensity reflected. But intensity transmitted, that's a whole nother story. It's sitting here looking at you like, hello.
Don't forget me.
Exactly.
I know.
She gets it. All right. Intensity transmitted is looking at you like, you know, I'm here. What you gonna do about it, you know? You gonna get me a pizza too? So you get it a pizza. You get it a pizza to pizza, you know? So intensity transmitted, first you have to find intensity transmitted coefficient. Boom. So you take the ITC equals 1 minus your IRC, what you found up here. And that gives you the intensity transmitted coefficient. And then you go ahead and take, to find your intensity transmitted, your initial intensity times your ITC. So these equations right here will get you where you need to go, get you to the future, get you ahead. Don't look back. Something's behind me right now, I'm not looking back. We keep going. So now, let's solve the problem. First step, IRC equals impedance number 2, which your impedance number 2 right here, Z2, Z1. Simple. Equals 51 rails minus 49 rails over 51 rails plus 49
rails.
I was waiting for it. There we go. And then you gotta square that. So now you go ahead and solve for this. IRC is going to equal 51 minus 49. That's 2 over 51 plus 49. 100. And you square that. 2 divided by 100. You know, as short as you can be, you always got to double check. That ends up being 0.02, and you square that times 0.02, and that ends up giving you 0.0004, and this right here, my friends, is your IRC. But are we solving for the coefficient? No! We're solving for intensity reflected. So you take this IRC right here and you plug it in back to this one right here. IR equals IRC times initial intensity. Boom. So IR equals your IRC 0.004. Oh, 04 times, make it look pretty, your initial intensity of 2 milliwatts per centimeter squared. 2 milliwatts per centimeter squared. All right. And you just do the math for that. Times 2. So your intensity reflected, we solved half the problem, is 0.0008 milliwatts per centimeter squared. So that's half the problem. We took up a lot of real estate, so we're going to have to push on this way. So we solved for the intensity reflected. That's this right here. We got half the problem figured out, but we need the other half. So what do? We solve for the other half. ITC equals 1 minus IRC. So now we're looking for ITC, which is your intensity
Coefficient.
transmitted coefficient. Yes. 1 minus IRC. So your ITC equals 1 minus our IRC. Remember, that's our intensity reflected. You want to get the intensity reflected coefficient. That's what this was. And that's 0.0004. And that ends up coming out to 1 minus 0.0004. Our ITC equals 0.9996. So we solve for ITC. It's right here, your ITC, your intensity transmitted coefficient. And now we go ahead and solve for the intensity transmitted, the actual IT. So right here we take your IT equals IO, your initial intensity, times your ITC, which is right here. So our initial intensity, if we come back to the problem, was, where's it at? It was 2 milliwatts per centimeter squared, 2 milliwatts per centimeter squared, times our ITC of 0.996.
One more 9.
0.999. Yes. All right, so 2 times 0.9996 equals your intensity transmitted is 1.999992. But we just round that to IT equals 2 milliwatts per centimeter squared. There you have it, folks. You solved for intensity reflected, you solved for intensity transmitted, and now you're finished.